Hello, chemistry family. We are on to mole conversions, and this is one-step mole problems, worksheet number 2. So let's take a look at number 1 together. I'm starting with 13.7 grams of oxygen, and I want to convert that to moles. Now to do that, I can use my mole map, and I have to think about it. If I'm in grams, I'm going to start at mass island, and if I'm going to moles, that means I'm going to take this bridge right here, which means I'm going to use this conversion factor. Now remember, if I'm looking for molar mass, I want to find the mass of the object off the periodic table. Since I'm dealing with oxygen, O2, that's like adding up 2 oxygens, which on the periodic table are each 16 grams per mole, which is a total of 32 grams. So that is the number I'm going to use for my molar mass. So now I can literally just use my mole map and plug right in, and that's what I'm going to do. I'm going to always start with the number I'm given, right? You have to start with the number in order to do a math problem. So 13.7 grams of oxygen. I'm going to multiply and draw the line, and now use my conversion factor. It says to put 1 mole on top, and since I'm talking about O2 oxygen, I'm going to put that as well for my label. And on the bottom is molar mass, which we found out. That is 32 grams of oxygen. And remember, this conversion factor, this fraction, is really just 1 over 1, because for every 1 mole of oxygen, there is 32 grams. And 1 over 1 divided by 1, 1 divided by 1 is the same as 1. So that's why these conversion factors or fractions work. But anyways, look at what happens naturally because of the map. Top grams of oxygen and bottom grams of oxygen are gone. You're now left with on top your moles of oxygen for your unit, which is what we wanted. And now we can just do our math problem. Remember, you take your number, you multiply the number on top, and divide by the number on the bottom, which really is just 13.7 divided by 32. And the answer you end up getting is 0.428 moles. All right, simple as that. Let's look at question number 2 now. All right, I've got 65.2 moles of water, and I want to go to molecules. All right, so first of all, I'm starting at moles, so that's mole island. I'll use blue here to start my new problem. And I'm going to molecules. If you look, molecules falls under particles. So that means I'm headed to particle island from moles, which means I'm just going to use this conversion factor right here. There's no additional math to do, nothing like the molar mass that we did earlier. So this just becomes very straightforward. I'm going to take my 65.2 moles of H2O, which is water, multiply it by that conversion factor up here. On top it says to put Avogadro's number, 6.02 times 10 to the 23rd. And since I'm looking for molecules, I'm going to put it in molecules. I'll put MC for short, H2O. That's molecules of H2O. And then on the bottom, it just says to put 1 mole. Some people get confused and say, whoa, do I need to put a number there? Oh, they already gave you a number, 1 mole. So you're good to go. All right, and I'm going to label that as H2O because my moles of water are going to cancel out. I'm going to be left with units of molecules of water. All right, in order to do this math problem, right, we always take the number we start with, which is 65.2, multiply it by the top, which in this case is Avogadro's number, 6.02 times 10 to the 23rd, and then divide it by 1. Again, remember, when you're putting in your scientific notation in your calculator, make sure you're using the scientific notation button. For a lot of your calculators, that's like a second E button. So there are extra videos on that. I link that in our class schedule. Take a look at that. If you are getting the wrong answer but doing your math right, it's probably you're just putting in your calculator wrong. All right, but let's throw that in the calculator, 65.2 times 6.02. In the end, and forgive me, I'll throw it up here just above the problem. The answer is going to be about 3.92 times 10 to the 25th. And that is going to be in units of MC for molecules of H2O. Sorry I had to jam it in there for the answer, but at least you get the idea of what's going on. All right, so the first 2 problems done for you. We're using the mole map, cruising along. Let's try the next 2 problems together. Problem number 3, looks like we're starting with 789 moles of sulfur dioxide. Okay, so I'm starting at Mole Island. And, it says it's a gas at STP. That should be a hint to me right away that if I need to convert to volume, it has to be at STP in order for these fractions to work. And in this case, since I am going to liters, that's exactly what I'm going to be doing. I'm going to be solving for volume, right? So I'm going to take this chart right here, or this bridge, to go from Mole Island to Volume Island. All right? To do that, I'm going to use this fraction right here. No big deal, no additional math necessary. So I'm going to take my 789 moles of sulfur dioxide. I am then going to draw my conversion factor, put 22.4 liters on top. Why? Because that's what it says to do. And put 1 mole on the bottom. Remember, MOL is the shorthand form for mole. Don't forget to label properly. I'm going to put SO2 because I haven't converted to anything else yet. So SO2 is for everything. Eventually that'll be important because we will be converting to other things. But the beautiful part about these conversion factors is moles of SO2 cancel out, and I'm left with liters of SO2, which is important because I wanted to convert to that. To do my math, I just take the number I start with, multiply by the top, which would be 22.4, and divide by the bottom, which would be 1. And I guess you don't really have to do that last part, but 789 times 22.4 ends up being 17,673.6 liters of SO2. Notice that my units up top here are the same as my units up here. All right? So that was a pretty straightforward one. No additional math required for the conversion factor or the fraction, but that was nice. I'm going to erase up the answer here, so write that down in order to make room for question number 4, and then we'll get going. All right, question number 4, you have 76.24 grams of H3PO4, which is another way of saying phosphoric acid. Now, since I have grams, that means I'm in mass, and I'm trying to go to moles, which means I'm going to go to Mole Island. So to go from mass to Mole Island, I am going to have to take this top conversion factor. Now, since molar mass is part of the fraction, I am going to need to do a little bit of extra math. Since it's H3PO4, I'm going to need to add up 3 hydrogens, 1 phosphorus, and 4 oxygens. Go ahead and look on the periodic table. You can pause this, add it up, and see if you end up getting the same answer as me. But when I end up adding everything together, I get about 97.97 grams for my molar mass. That's going to be helpful because now I can set up my conversion factor. On top is 1 mole. Why? Because that's what it says at the mole map. And that's H3PO4, phosphoric acid. Let me see if I can move this a little bit up. There we go. So that I can get some room here. All right, and then on the bottom, no big deal. We are just going to put our molar mass, which we found from the periodic table. I got about 97.97 grams. And again, I'm going to label that as the compound we're talking about, which is H3PO4. All right, the beautiful thing, grams of H3PO4 cancel out. I'm left with moles, which is exactly what I was trying to solve for. So I'm going to plug that in. Remember to multiply by the top, so 76.24 times 1, and you always divide by the bottom, which is divided by 97.97, and you end up getting an answer, and check to make sure that your calculator work is the same as mine, is 0.778 moles of phosphoric acid, H3PO4. Boom, we are flying along. Let's try the next 2 together. At least you have a good first 6 problem start for support in case you needed it. Well, I'm having a great time with this. Let's go to number 5. I'm starting with 789 moles of C6H12, okay? So that's moles, and I'm headed to grams, which is Mass Island, which means if I can turn to red here, I'm going to take this bridge from moles to mass and use this conversion factor. Now heads up. Molar mass is there, which means I need to figure out the mass off the periodic table for all 6 carbons and 12 hydrogens. All right, how do I do that? Simple. 6 carbons added up plus 12 hydrogens, and what I end up getting for an answer is about 84 grams for my molar mass of that stuff. All right? Check and see if that's what you get. But let's start plugging that in. I'm going to write down the number I'm given, 789 moles, and I do want to label it with what compound it is. Remember, eventually we'll be switching compounds, so labeling will become very important. I'm going to use this conversion factor, so I'm going to put my molar mass on top, 84 grams. Remember that 84 grams came from us finding it off the periodic table. And then on the bottom it just says to put 1 mole. And again, I'm going to label it as C6H12 because we want to get used to labeling. When things start getting confusing with more compounds, it'll be a big help, so we'll get used to it now. Moles of C6H12 cancel out because on top and bottom, numerator and denominator, they will naturally divide out, and you're left with grams of C6H12, which is exactly what you wanted for your units. So this becomes just straightforward math. We multiply by the top, so it's going to be 789 times 84. We divide by the bottom, which is divided by 1. And what I get for an answer is about 66,276 grams of C6H12. So that's 66,276 grams of C6H12. Perfecto. If we try number 6, oh, here's a big one. We've got 451 million formula units of CH3OH. And that's technically a typo. That should be molecules. That definitely looks like, well, I guess if it's OH, it might be ionic, but I'm pretty sure that should be molecules. Forgive me for that typo. But anyways, we know that we're going to be dealing with formula units or molecules, which are particles. So let me circle that with the new color so we don't get confused. So we're starting with particle island, and we're going to end up at mole island. Now, some people say, well, wait a minute. It says it's a gas at STP. Doesn't that mean I have to worry about volume? Oh, good point. If you were going to convert to volume, you could because it's at STP, but that's not what it wants. It wants you to go to moles. So you're literally going to take this path right here. All right? So I don't think it's trying to trick you, but you do have to pay attention where you're starting and where you're going. A lot like life. All right. So I've got 451 million, and that probably should be molecules. I'll have to look that up, but that looks like all nonmetals. I don't believe that's coming together as an ionic, so that should be molecules. And now that I'm doing that, I have this top fraction I'm going to use. And it's going to be 1 mole on top, just like it says, and that's of CH3OH. All right? That's methanol, by the way. And then on the bottom, we're going to put our 6.02 times 10 to the 23rd. Remember, that's Avogadro's number, and that's what's on the bottom. As long as you follow your map, you'll be good. And that is going to be molecules of CH3OH. All right? Here we go. Let's chug it away here. We're going to multiply by the top number, so it's going to be the number given to you, which is this big one, times 1, and then you always divide by the bottom number. Again, careful when you put in your calculator. I suggest using the scientific notation function. But when you chug that out, you end up getting about 7.49 times 10 to the negative 16th. I would say that's technically a molecule, CH3OH. All right? If you are not getting that, or you're getting the base number but not to the negative 16th, it's something in your calculator you did wrong, okay? And that's a little red flag. You want to check in on that. All right, so we ended up getting 7.49 times 10 to the negative 16th molecules of methanol. All right, hopefully this is a great starting point and some more support for you in case you were struggling. But using the map, straightforward, should become more and more comfortable, especially when we start moving into two-step problems, where, simply enough, you are going to head perhaps from something like mass island to volume island. And to do that, you just have to follow your map. Go mass to moles, and then moles to volume. And as long as you can use your fractions, it will be very straightforward. but we're headed there next. So thanks for listening, ChemFam. Best of luck with this, and ask questions in class if you need it. Bye-bye.